brief introduction for context. I'll try not to make this too much of a sales pitch, but we're doing a lot of interesting things. I think are interesting, and I'm going to try to put a few things up there for you. And if you're interested and want to ask some questions or just have some feedback or some connections that we should make as we pursue some of these projects, please let me know. So CNC Router Parts is a company that myself and two other partners created to build industrial CNC machines, not just necessarily cutting, but CNC manufacturing systems that were industrial grade, but things that could be packaged and delivered for startups, for home enthusiasts, for people running a business out of their shop. They didn't have to compromise with a plastic CNC machine or something really ultra optimized for shipping weight. What we do is we provide machine kits that are ready to assemble, including electronics and mechanicals, and the spindle and anything else you need. And what it does is it comes delivered kind of like an IKEA situation. You get 6 boxes, each weighing less than 60 or 70 pounds each, and you have a good weekend of it. But we use the same software that IKEA uses to make the assembly manuals. We're all on the desktop and all that stuff. So it's a good manual. Depending on the machine, it's a weekend, or if it's one of our benchtop machines, it's a couple hours. But that's kind of our business model. And in return for that, for doing our bidding, our labor for us for that awesome industrial machine, it's usually around half the price of what an equivalent machine would be otherwise, fully assembled, like from a major manufacturer like ShopBot or etc. So that's kind of what we do and what we came from. We were founded in 2007. But earlier this year, we thought it would be cool to take our systems and start doing some other things other than just subtractive manufacturing, like we talked about earlier, but additive. So we've developed this 3D print head as kind of an initial offering. It's optimized for printing larger things. It's printed some very large things, but it's kind of niche. It's printing things like this 10x Lego man fairly quickly. So on a conventional printer, a small nozzle printer, this would take an exceptionally long time. This was about an 8-hour print, mostly because of the infill in here. But because we're able to support nozzle sizes, the nozzle's the diameter where the filament flows through at the end, we're able to support something around like 1.2 millimeters as a small nozzle, whereas a traditional consumer 3D printer would start out somewhere around like 0.3 or 0.4. We go all the way up to 3 millimeters with this print system right now. The other thing that we thought would be kind of cool to do with this is make this plug and play with existing CNC electronics. So 3D printing came out of the CNC world, but then kind of went its own way. Its G-code's a little bit different, it calls it the E extruder instead of A extruder. We tried to marry those together under the software covers and the hardware level. So the actual print head itself is simply shaped like a router. You take your router out that you used to machine apart, maybe make some wine glass holders at Bamboo or whatever, and you put in your 3D print head, connect it to the same industrial connector that you had your cutting tool connected to, and submit your 3D print file that you created in either Fusion 360 or some other CAD/CAM tool. So adding the 3D printer together obviously exploits a few new ideas. One is you get one really nice machine that can do multiple things. It can do cutting, it can do additive manufacturing. You can do both at the same time, right? Not necessarily the exact same time, but within the same workload. So we've also developed software that'll help you auto-position things that you've 3D printed to do cutting operations. One of the challenges with 3D printing is the general mushiness of it. At its worst, it is a hot glue gun squirting material out, and with almost no regard for tolerance or things like that. So if you have things that need to be threaded or bores that need to be smooth, the complementary action is to print it and then machine those parts to specifications. So we've done that for different parts of car interiors, for example. One of us, myself actually, has a DeLorean, and it's hard to find certain parts for it. And part of,
It's in the future.
It's in the future. I'll be here in a few days. I totally did car debt. I gotta get to. Soon. So, when you have a car that has parts that are hard to obtain, especially plastic parts, where the startup costs for injection molding are pretty high, having a large format 3D printer can be helpful. And the ability to polish up what you just printed can help authenticate that, yeah, I 3D printed this. It's kind of cool to tell people for technical grins, but at the end of the day, what's important is the part that comes out, not the process. So we talked about the print tool a little bit. It's awesome. That's more to say. It's going to be out probably around January or February. not quite in time for the Christmas holidays. It's one of those things, we started prototyping it with a lot of commodity parts, and by the end of the day, it's all stuff we developed. So we have our own gearhead extruder to move normal filament, but at much higher speeds. So the flow rates on this thing would take a standard filament spool and just unwind it like you wouldn't believe.